Welcome back. I wanted to say a couple things, and then we'll do example of a small number. So, yeah, this may sound a little weird. 870 megameters. You probably never heard the phrase megameter. That's because the Earth, the radius of the Earth, is like 6.5 megameters. I think. I was looking it up here. 6.3, 6.4 megameters, which you can call 6.4 megameters. Let's do this one real quick. So 6.4 megameters is you've never heard of a megameter. I never did either. We just made it up there. I'm joking, but it doesn't show up too often. You're probably more used to seeing these guys, which is a kilometer, which is a kilometer. And the kilo, I hadn't written the kilo up here. The kilo is 1,000, and it's equal to 10 to the third. And so let's see if we can change this megameters into kilometers. Kilometers. So we got 6.4. The mega is 10 to the sixth, and we got the meter. I made a mistake, right? A mega is 10 to the sixth. Okay. The kilometer is 10 to the third. So we'd like to do that same kind of trick, and we like to write this guy as we'd like to get a 10 to the third out of there. But in order to get to 10 to the third out of there, what are we missing?
Another third.
Yeah, so we need 10 to the third times 10 to the third is 10 to the sixth. So we can break it up this way. And this guy, we can call him the K. So 6.4 megameters is also 6.4 times 10 to the third kilometers. Or, like I said, we tend not to mix and match the scientific notation with the metric prefixes, so what's another way to write 6.4 times 10 to the third?
6,400.
Very good. Just you move the decimal over 3 places and you get 6,400 kilometers, which is also 6.4 megameters, which happens to be this is the radius of the Earth, right? 6,400 kilometers. Something like the runners know this one. A kilometer is 0.6 miles, so this is something like 3,600 miles is the radius of the Earth, approximately. All right, let's do a small one. So a small number is something like 0.00000000. I'm gonna do something like that. Okay, to make it fun, we'll give it some units. The units are meters. By the way, the meter, if you follow me over here, what's a meter, you ask?
A longer yardstick.
Yeah, this is a meter. Meter is the metric unit of distance. So everything's based on this guy. It's a little bit long. If you turn it over, it's about 39 inches. So it's a little bit longer than a yard. So you can kind of think of a yard and a meter. It's pretty much the same thing. So now we're going to look at this number. This is a small number. And we know this is the ones place. So what the heck place is this? If we don't have anything here, but this would be the tens place. Where did the 10 come from? Well, that comes from 10 to the first power. And over the next guy would be the hundreds place, which is 10 to the second power. Who the heck is this guy?
The -1.
Yeah, so this, I think most people are comfortable know that this is like the 1/10 place. And 1/10 is 10 to the -1. 10 to the minus 1, I'm gonna get a little sloppy here, I'll write over here. 10 to the minus 1 is equal to 1 over 10. 10 to the minus 2 is equal to 1 over 10 squared, which is equal to 1 over 100. 1/10 is also, can be written as 0.1. 1/100th is 0.01. Right? And I can get smaller and smaller and smaller. So that's what these guys are. These small numbers are to the right of the decimal, and every step you go over, it gets smaller by a factor of 10. Okay? So we want to write this guy in scientific notation. So we play the same sort of game. That is, how many places do we have to move the decimal? So here's the decimal. We got to move once, twice, 3 times, 4 times, 5 times, 7 times. Got to watch my counting. I guess I can do this: 2, 3, 4, 5, 6. So we got 4.75 times 10 to the. I had to move the decimal 7 places.
Minus 7.
There you go, but it's I had to move it to the right. That's negative powers of 10. So that guy's equal to 4.75 times 10 to the minus 7 meters. Okay? Now, just because we're having so much fun, there's also metric prefixes for the small stuff. And the metric prefixes for the small stuff are for 10 to the minus 3, which is 1/1000th. We got the milli. We use a little m for that guy. 10 to the minus 6 is micro. We use the Greek letter mu for that guy. 10 to the minus 9. Nano, which is technology is just beginning to be able to do stuff in the nanometer range, and we use the n for that guy. We'll stop right there with the metric prefixes. So let's try again. Let's try to write this guy using a metric prefix. And once again, we don't have a 7.
No.
We got a 6 and a 9, or a minus 6 and a minus 9. Okay. We're gonna shoot for the minus 9. Okay, I'll show you why in a second. So here's 10 to the minus 9. But in order to have 10 to the minus 9 in here, you know, who's missing, if you know what I mean. So we got 4.75 times.
The 2.
Okay.
Positive.
Very good. So I need a factor of 10 to the positive 2, because 10 to the 2 times 10 to the minus 9 is equal to 10 to the minus 7.
Yeah.
Okay, so that's very good. So what's another way to write 4.75 times 10 squared?
47,500.
Um,
Oh, wait.
boom, boom. Does that help?
We gotta add the zeros, huh?
Well, yeah, no, it's just 2 powers of 10. So I just
Yeah.
moved the decimal over twice.
Yeah.
So it's 475.
Oh,
Right?
uh-huh.
And so 475 times 10 to the minus 9 meters, or 475 nanometers. Okay. So that's kind of cool. In fact, this is like blue light. Blue light has a wavelength similar. You know, well, there's a range for blue light, but this is in the blue range of the visible spectrum. All right, good fun. Have a good day.